So I would like to talk about the initiatives of Abyss, a vertical search platform. I am Takeda from Yahoo Japan. So this is today's agenda. First, let me introduce myself. So what do I do? To answer this question, please refer the conference presenter introduction part. And what do I like? My answer is I like fast things, especially cars. My internal snack icon is a Mini 4WD. It explains what I like. I assemble it by myself. This weekend, there is a final race of the Formula One is going to be held, so I am going to watch it. So, ladies and gentlemen, do you know search is not only a search box? In Yahoo Japan, by linking Yahoo Japan ID in a format of the recommendations, implicit searches are carried out. Then I would like to ask one question. So left-hand side, which area is using search technology? Searching website is the search itself. Also, the result of the searching weather is displayed here. And also the number of the unread emails is the result of implicit search. And in the e-commerce, the searching merchandise. And also there is a searching transit information. So almost all services in Yahoo Japan use search technology. So search is a necessary technology for Yahoo Japan and also for you. Abyss is a search platform to support these Yahoo Japan services. Then, what is Abyss? Abyss is often translated as deep or profundity in Japanese. So it comes from Greek abyssos, meaning deeper than bottom. It's often used as a bottomless pit or hell. Then is a platform Abyss named after hell? The answer is no. Abyss stands for Automated Building Yahoo Search SDK. Although it says SDK, it doesn't offer SDK now, only the name remains.
Abyss history is old. In 2010, Abyss 1.0 was launched. Afterwards, in 2014, core technology is the same as Abyss 2.0, which was also launched. Out of this Yahoo services, we have been using in-house search engine before we used Abyss. And 1.0 is the in-house search application. Now, why Abyss was born? Before Abyss was born, there was an in-house service application is packaged and published. And the service team was installing it into the actual server, and the service owner was doing maintenance and operation. So there has been improvement of search results per service, and performance fine-tuning has been done, and which has been stored as knowledge. But for some services, latest server was in use, but for other services, 1 year old server may be used by different vendor, So even if knowledge is shared, as a runtime environment is different, there was no guarantee for us to make it work well. To resolve such an issue, Abyss was born as a common search platform. As we make it a platform, knowledge with high reusability can be concentrated in one location. By so doing, success case for one service can be deployed to other services. Using Abyss, search experience can be improved with Abyss, which is the foundation. And as shown on the left, service and the platform, there are roles of them which are clearly defined, and the platform team can focus on reducing operational costs and tackling latest technology, whereas the service team is focusing on the improvement of services. From now on, I'd like to talk about the current version of Abyss. For the current Abyss, Apache Solar is the basis. Apache Solar means that it's an open source full text search application which is written in Java. And the Java interface is implemented. By so doing, the feature is that you can expand functionality. And using Solar, Abyss has become a common search platform, and they will be offered as part of a managed environment, including B2B. It is in use for over 100 services by Yahoo Japan. There are over 10,000 virtual machines working. And as a platform role, reducing operational costs and also incorporating latest technologies, which are the focus we have. First of all, I'd like to talk about the initiative to reduce operational cost. Abyss is built in in-house virtual environment for our data center, as this is the environment where we manage. Rather than using external cloud environment, it is less expensive to maintain servers. And also, not only the virtualization of servers, using a container technology, Solar is uniquely packaged. Using the same version, container image is that the plugin version is also the same. Therefore, it is easily reproducible, the environment on different VM as shown on the left. Abyss loads data, and it should be included as a search target, which is named as a feed. The data fed to Abyss will be outside of a container, and it will be stored on VM, as shown on the left, outside of a yellow box, or it is stored in blue box. Data stored in VM, it will not be deleted. When there is an anomaly is detected, you don't have to be concerned about the data loss to recreate a container for implementation. However, because of a physical layer failure, there are some cases where data on VM may be deleted. As you can see on the screen, it is reliant on physical layer. So if there is a failure of physical layer, there is a possibility that the data may be lost. As a measures, minimum 3 replicas should be given per one shared for redundancy, where the Solar replication feature shared as a whole, data will not be deleted. However, it's not secure enough. Multiple replica in shard are operating in physical layer, the same physical layer, and there is a risk where a single point of failure may happen. which is risky. As shown in the diagram, VMs on shard may be running on the same physical layer. Because of the failure of physical layer, there is a possibility that data may be lost, which is risky. But it may not be all of the data gone. But if two of them in this diagram may be running on physical layer, which is also risky, because a VM that fail and the other VM needs to respond to requests. Remaining VM may receive 3 times more of requests prior to the failure of VM. And in order to avoid such a risk situation, checker component exists in Abyss. Checker will make sure that there is no SPOF in physical layer. If SPOF is detected, Abyss team should replace it with different VM for operation. Next, I'd like to talk about Abyss configuration. First of all, the one on the left in this diagram, you can see a request from a user going through routing server, and it goes to Solr. And the user and the routing server will have a service, web server, and other web user interface. And next, the one on the right, service team from web UI can change the configuration and view the log, which is the same as common cloud services. Configuration change for Solr is done through internal API. And the internal API, depending on the content of a change, subcomponent for Solr, Zookeeper may be controlled, or Solr client, by which Solr cluster may be operated, or HTTP requests might be sent directly to Solr server. As for operation through in-house API, that is to try to avoid operational mistakes. And for Abyss, in addition to monitoring server, there is a component to support the operation. Checker and repairer exists. As for checker, I mentioned SPOF checking is also done. It's not per node, but it is checking healthy of the entire Solr. And as for repairer, that has a role of auto healing. VM vendor is disclosing failure information. You can request to API, and if there are servers that are recovered, we can restart the VM. And this is the summary so far. Abyss for virtualization, SPOF removal, and auto healing are taken place. By so doing, even if there are 10,000 servers, it is a platform with which you can spend a good night with peace of mind. Next, I'd like to talk about incorporating the latest technologies. We sometimes get query like this for Abyss several times a year. If this search can be done as shown in paper, we can offer better search experiences to users.
よくある機能要望
So this is a common feature request. And many engineers would answer like this. So please wait until the function is implemented in the application. The version that can use it is released and our operation check is completed. But we cannot wait for that. So Abyss, platform team and science team work together and realize the service requirement. So when Abyss was born, there was only service and platform, but also the science team is involved. So all teams are working together to realize service requests. So science team, as a solar plugin, implement the solar extensions, and the platform incorporates them into the Abyss and offer the environment to the user. And service actually can use the requested functions earlier than the solar natively supports it. And let me talk about the ANN plugin to realize that case. ANN is a vector search, and it's a way to speed up process by using approximate value. So compared to the full text search, the accuracy is a bit deteriorated, but the time to get the response is a lot faster. So recently, the image search and the natural language processing area, vector search draw the attention. And also in the area of the full text search, like Solr, vector search, and also the ANN feature addition is requested. May 2022, the Solr 9.0.0 was released, and with that release, the Solr can support the ANN function natively. Then, what was the situation of Yahoo Japan? So to demand of the ANN in the vector search, science team started to address it in Yahoo Japan. In 2020, science team developed ANN as a solo plugin, and after that, the plug was incorporated into the solo container image, and the Abyss team did the assessment of the behavior and performance, and also the impact to other plugins, and started to receive the usage. And first user service consultation was made June 2021, and service side performance test and also A/B test was conducted, and superiority was confirmed. So it was switched to ANN plugin in October of 2021. So the Abyss incorporates many in-house extensions like this. So popular in-house extensions I would like to introduce to you. So Japanese morphological analysis tokenizers. So there are two tokenizers are used often, even though the Solr natively supports the Japanese tokenizers. TPR plugin is available to do the multi-phase ranking, but also it can handle the dense vector. So this is a multifunction plugin. TPR plugin can abstract the Solr process, so it can handle many processes with one plugin. ANN plugin performs the vector search using approximation. So dedupe plugin does deduplication. So summary so far. Abyss as a common search platform, operation cost reduction, and also incorporating latest technologies carried out. So from now on, I would like to share some use cases using Abyss. So first case is a timeline of Yahoo Japan application. So Yahoo Japan app home screen, then the search result by Abyss is displayed in the timeline. And so of course there are pre and post process. So timeline where many articles appear by scrolling. So let me talk about the requirement of the timeline. The first requirement is that, so what kind of article the user is interested in, and tap the thumbnail. It depends on the people. So the topics top of the screen recommend the same article to everyone. So the timeline should recommend the article according to individual. So this is the requirement. And the second requirement, the article, the freshness is important. So the just created article should be recommended. Then the probability to read the article is increased. So batch process every 5 or 10 minutes cannot fulfill this requirement. So to realize these functional requirement, this is the system requirements. And the first system requirement is handling the huge volume of requests, because the interesting articles are recommended. So article already are also recommended. So I think at that time you scroll the screen many times, and every time the scroll send request to Abyss, a number of requests is increased. In normal daytime, several thousands requests per second. Daily peak, it will be doubled, and breaking news is pushed. Everyone check the Yahoo Japan app, so the huge volume of the request is sent to Abyss. So the second system requirement is about the response. So when you scroll the screen, you want the next article is shown immediately. Of course, there is a pre and post process. So the average tens of millisecond and 99 percentile, the hundreds of millisecond within that time, the result has to be returned. Then the last system requirement is the advanced recommendation using machine learning. So, so there is a trade-off between the time and also the accuracy. So the balance has to be fulfilled, although the number of the requests is huge. Then how do we meet those requirements? In case of Yahoo Japan application timeline, outside of the Abyss, the two machine learnings are carried out, and within the Abyss, a simple vector search was conducted. So when the article is fed into the Abyss using machine learning, the feature of the article is extracted. Then the article vector is generated. The user, based on the machine learning, the user preference extracted and the user vector is generated. So the based on the similarity between the user vector and the article vector, the article is ranked. Then a timeline is generated. Please refer the reference material for details.
And in order to implement this search, what Abyss team has offered the environment. In order to meet those requirements, Abyss has many replica with a multiple number of clusters which were offered. As the number of requests is too much, one cluster cannot accept massive requests. Therefore, multiple solar class with identical data were prepared so that requests can be distributed. And also, machine learning is done outside of Abyss. It was not necessary to implement heavy processing on Abyss, and middle spec VM, and many of them were offered for the use. And from now on, I'd like to talk about the second use case. The second use case is called Yahoo Japan Knowledge Search, Chiebukuro. Abyss has a search of questions and also responses related to questions. So both of them are used. So Abyss is the core for Yahoo Japan Knowledge Search. And as for questions asked for Yahoo Japan Knowledge Search, there are unique characteristics of the questions that came to Yahoo Japan Knowledge Search, which means that for the question with good responses, it is repeatedly viewed. User comes to Yahoo Japan Knowledge Search to get an answer. So this is the information that should be posted at the top of this ranking. And when there is a collection of good answers, in order to score natural language processing, there was a limitation. Therefore, we scored that with use of machine learning. Next, this is about system requirements of Yahoo Japan Knowledge Search. First, system requirements is to have a question and answer in a massive amount. Launching a service in 2004, we have been accumulating services as many as 250 million questions for 18 years, and there are 600 million answers, and we are receiving more than 40,000 questions every day, even now. And there are requirements for response. The number of requests is some thousands requests per second in a weekday, and using machine learning, response speed must be some 10 millisecond, and they should be within some hundreds of milliseconds in 99 percentile. And then I'd like to talk about how we can implement the requirements. TPR plugin was in use to meet the requirements. TPR plugin was in use. By so doing, all the questions hit query. Rather than that, quicker response can be returned. As for first phase, morphine analysis ranking was carried out. As for question that was hit with search query, the number of words that comes often will be shown ranking, and also top n time was decided with the tuning parameter. And for the second phase, n plus shared number question was the function to score using machine learning, and the re-ranking was done with that score for top 10 search result. For your information, TPR, even with the TPR, it doesn't mean that we will always come up with this result. TPR plugin with a multi-phase approach is what we can take. Last but not least, I'd like to talk about Abyss team offered environment to implement this. In order to meet those requirements, high-end spec VM was utilized to offer large-scale cluster. And Solar is a full text search engine, and all the texts have to be on memory, which is the prerequisite to improve performance. Therefore, massive amount of memory was required. And using a machine learning model, score needs to be calculated. High-performance CPU was required. High-end spec VM to meet those requirements was in use. And the Abyss team offered Yahoo Japan Knowledge Search. And this is the summary so far. Abyss, depending on the service requirements, we offer Solar cluster and operate them. That way, service team can focus on the improvement of services. That is how we support them. And this is the conclusion of this presentation. Abyss is to service team can focus on offering a new value with Abyss and a common search platform, operational cost reduction, and incorporating latest technologies are used. And the Yahoo Japan app timeline is using vector search and articles that will meet individuals' preference are shown, posted. And the Yahoo Japan knowledge search, we have a two-phase search to limit computation so that we can have a good result. Thank you very much for your attention. Mr. Takeda, thank you very much. Now we will have a plus talk for the questions.
So we would like to entertain questions from audience as much as possible. So you can post your questions by a question mark icon on the screen. So questioner is Mr. Kifumi Nakamachi from LINE. So Nakamachi-san, please, floor is yours. So I am working the building of the assessment of the hyperchloride, and I am really interested in the search, and thank you very much for your presentation, and I have some questions. So first, in the title, the vertical search platform, as title says, other than the use cases you mentioned in the presentation, I want to know more the use cases. So I wanted to include more cases. Thank you very much for your question. And so the title says the vertical search platform. And so web search, to compare against the web search, I put these words. But there are several areas in a search. And so using a silo type vertical search. So to identify the difference from the web search, I use the term the vertical search. And what is the vertical search? I said the silo type. So web search, so using crawler and find out the search subject, but that is not the style of the vertical search. So we feed the data. Then from there, the search is carried out and the result is returned. That type of the search is called as a vertical search. And Abyss is the platform for such search. Thank you. So for example, so prepared data, what kind of data is actually you have prepared? So in case of the travel, so the hotel accommodation, so the available room, how many room is available, that is fed into the Abyss. So when you search in the travel, so if you go to the web page, and the web page article tend to be old, or the information from the individual's blog. So so it is important to have the actual available room information. So the hotel accommodation can enter the actual data. Then that data is fed into the Abyss, and you can search the Abyss, and you can actually find out the available room. Thank you. And in your presentation, so the expansion is realized quickly. That is great. And so with regard to the expansion, so the science team can add the plugin casually, or you receive the demand from outside like a ANN, and the extension is added based on the demand. So what kind of approach you take? So is there any criteria or the process to add the extension? I want to know that more in detail. Well, also I'm not sure to which extent I can share the information, because we work with the science team. So science team is participating the academic conference, so they get information from there. So based on that information, they do add the function, and also they add the function based on the request from other team and question from audience. So avoid the single point of failure you are checking. So I think it is better to deploy the VM in other physical layer from the beginning. Why you don't do that? Well, we are doing that. So there is a case that replacing VM because of the operation requirement. Then we switch or replace the VM, but the SPOF was created. So we check that every time the VM is replaced. That's my concern also. The page 38 of your slide, SPOF is found, and the Abyss operator should change the VM. So I thought that that portion could be automated. Are you thinking about that? Yes. So that happens sometimes, but to automate, so that is not automated at this moment. So that's the improvement point for the future.
Then there is a similar question. Which version 2 was released, and it's been some time since then. What are the changes you might have? For example, V2 operation, what are the things you are going to improve for betterment? Yes. Today, I introduced the point with 10,000 servers. You don't have to be concerned about the server failure. That is the initiative I talked about. But if there are 10,000 servers, there is another issue. Release operation is going to require lots of work. Although we are tackling that, but even if we automate, 10,000 servers are going to be released, which takes lots of time. So that is the point when we are continuously improving to accelerate at a higher speed. I see. And another point, Abyss is utilized by many services. I think this is a great platform. And platform as a service, maybe the way that you may introduce to Z Holdings in broader sense. Do you have such an idea in detail? Yes. At present, internally or externally, it's not a platform that is externally published, but there are internal case studies within Z Holdings. So it is a matter of proceeding you have to go through before you use it. I see. Thank you very much. So overall, it was informative, and I can take it as a reference. And other things, it's a small question. NLP was what I was working on. And for expanding features, native analysis, morphing analysis, I think there may be what kind of a concern you have, which is a rather small question. When it comes to Abyss, historically, it's been offered as a unique search engine, even from 1.0. Even before that, there are services for search, and those services are using Abyss even now. And those services, if a tokenizer of morphology analysis is changed, Abyss or from Abyss to Solar, if a Solar is going to be used with a unique search analyzer, it can be implemented as Solar. But if there is a change in morphological analysis tokenizer, there will be a great impact, which means it will result in different user experience. That's why we're using it. I see. So in order to support what was offered in the past, you can have those approach, and also you can add something new. Yes. And user dictionary for Japanese morphological analysis tokenizer will be available. We are getting a query. Unique Japanese morphological analysis tokenizer may be utilized. I see. Thank you very much.